Hi everybody, this is Rasmus speaking from Vulpes, and in this video I would like to present you the SmarTexMod project. SmarTexMod project has been sponsored by hubcap and has been conducted by two companies, the Intelectronics, which is a Bulgarian-based company, and Vulpes Electronics, which is based in Germany. The purpose of this project is to enhance the efficiency for the design, development, and prototyping of smart clothing items, since the challenge for many designers is that is the integration of electronic components and technical components into textiles, and currently there is no digital tool available which can simulate it in the design process, but also in the development and in the prototyping process. So let me show you how it works. Basically, we have created pre-built assets which can be found on the web-based application, SmarTexMod.com. You first of all selecting one of the main asset types. It can be an electrode, can be a lighting system, or it can be a controller. In this example, I'm going for the controller, selecting the different custom diameters. The custom diameters are depending on, let's say, the size of the PCB of the electronic parts which needs to be used inside the clothing. Let's go for 25 millimeters, and now I have a preview of the asset. So this is our controller. I can also, let's say, enlarge the asset and have a look at it more in detail. And now I'm able to choose between different formats. I'm going for the object formats, for the object format in order to import it into the design clothing software. But I could also go for a MDL, for example, if I would like to do a rapid prototyping in order to have a more haptic approach on doing integration of this controller into my clothing item. So I'm downloading the controller into my download folder, and so the second part is I'm going into Close 3D. Close 3D is one of the most used designer tools for creating designs, and I'm going to import in a pre-built and pre-configured shirt. I'm going to import now the object file which I've downloaded of the controller itself. So now it has been imported. We can see that quite frankly here beneath. Let me just. So it's 3D type. So basically I can have a look at the item myself. And now I'm able to place this item depending on what kind of application do I have. So many customers, or let's say many designers, are putting the controller in an area which needs to be very best reachable for the use. For example, if I would like to control my heating system or my lighting system or something else, I'm going to do that by placing it on the chest part. And in this example, I'm placing this, for example, on the on the left chest part. So now I'm seeing in this controller, which is placed on the shirt, I have of course the option to download more assets, to put more assets inside, for example like the battery part or connection cables, and can put the structure to the shirt. When I've done with my placement, what I can also do is I can also do again the rapid prototyping, printing this, preparing a shirt, and try it out in the real conditions. But in the end of the day, I can also work with placements and with integration by shaping the assets, or let's say placing the assets into different directions. What I can also do is, of course, I can try to put it for design purposes more in the lower part, which might be better in terms of design or fashion aspects, or I can also simulate with the sizes and also.
So we've been using model-based design in our business since the beginning. So for the last 5 years, we've been using model-based design, and we've been using model-based design with in different areas of industry. So we've been using pattern design software. We've been using electronic design software for PCB layouts, also hardware for 3D printing technologies, and we've been putting everything together. And the advice I would say for other companies is really to use the resources that are available online, such as the one that we have made available for everybody through the Hubcap project. So to use the resources and not to develop from scratch new designs, but rather to quickly iterate on models that are already available, make them, produce them, and then see what are the shortcomings of those problems. And then when you have a clear feedback on what are the problems with existing models, then you can develop a new model that suits your need perfectly.